An ant colony population P at time t days grows at a rate given by the equation dp dt is 0.01 p, 100 take away p, for times between 0 and 4. The graph of the population is shown below, and we can see it's a standard logistic sort of graph. For t between 0 and 4, using the growth rate equation, explain the variation of the population. So let's look at this. dp dt is 0.01 p, 100 take away p. If we were to graph dp dt against p, it's going to be a quadratic. And dp dt would be 0 when p is 0, and also 0 when p is 100. We can see that p is 0 would make dp dt 0, p is 100 would make this bracket 0, and therefore dp dt would be 0. And the maximum would be here when the population is 50. And that's exactly what we see here. So we have low growth here, and the point of inflection just here when p is at 50. And I would mention all of those things and probably draw this graph as part of the answer. At the end of the 4th day, the environment for the ant colony improves dramatically so that its limiting population is increased to 300 instead of the 100 that we had here. Sketch on the axes above the expected variation of the population for t greater than 4 days using the increased limiting population value. So we can see here that this would asymptote towards 100. But that's not going to happen anymore. It's going to asymptote towards 300. So we're going to have a graph that goes logistic. It should have the point of inflection now at 150. Think back to this graph here. And so it's going to increase from there, have its point of inflection here, and then start to curve over towards 300. They said that they weren't, this was in the mark scheme, they said that they weren't worried exactly on where this was horizontally. It just needed to be at 150 this way, which is just as well because it might be difficult to work out where it is horizontally starting from this point, especially since this part of the question is only 2 marks.